The system board has a very high clock, 50 megahertz. So we're going to slow this down by dividing that by 2 raised to 26. And we're going to use 3 binary cascadable counter. So basically 2 to the 2 to the 26 is the same as 2 to the 20, which is 1 mega, and the 2 to the 6 is 64. So we're going to divide this 50 megahertz by basically 50 by 64, so that is approximately 3/4 of a hertz, almost 1 hertz, almost close to 1 cycle per second, actually 0.75. So we will pick up 3 components from the library component of Webpack, made up of 116-bit binary counter divider, 8-bit, and a 2-bit. So that totals up to a division by 2 to the 26 to produce that 0.75 hertz. The counter we're going to use require us to enable the clock. So there is a so-called CE. We will attach the board, field programmable board Spartan 3 clock enabled to switch 0, slide switch 0. And we have a reset external signal which we will commit to the push button 3 of the board. We will assign the 4 LED LED 3210 to the output of the 4 flip-flop, supposed to be A, B, C, D. But Webpack does not allow us to use the C because they are committed to the primitive component or macro component from the library, C for the clock. And A1 we will use for A in same difficulty. So the final circuit that we will come up with, which we will show later on in real time, is somewhat like this for the 4-bit Johnson circuit, employing library components and using the recent Webpack 9.1i, actually 9.2 is already available. Here is the dividing chain of the 50. This is the 50 megahertz clock. We will connect to this the clock enable signal. We will use a data flip-flop with clear we will pick from the library, which I will demo to you. From our equation, the data input of A is coming from B, the data input of B is coming from C, the data input of C is coming from D, and the data input of D flip-flop is the invert of A. We connect all the clock inputs synchronously toggled by the timer complete output of the division chain of the clock. We will connect the clear line of the counter as well as the 4 flip-flop data flip-flop we have to a reset input